Thank you, Cheyenne. And while Cheyenne is helping you with that, I will go on and get a lecture started. But Cheyenne, just go right ahead. No. Just finish up. Get them all. Get them registered. There's no time like now. So we are back to isoquants and production functions. And I know it's hard to do three things at once: pass in homework, get your voter registration forms done, and listen to class. But we're going to try it. It's a new concept. All right? Hey. Thank you. Silence in the court. So we're back to isoquants. And here I've written it in classic set notation, which if you took math in the new math world, see the Tom Lehrer song, would be very easy for you. And what's an isoquant? It is the set of techniques that are efficient and produce the same output. You could say it in words. New concept, which we probably use more often than we use the isoquant, is the idea of production function. So it's just inputs on the right-hand side, output on the left. Output is some function of the inputs. Notice this is only going to give you the relation between efficient inputs-output pairs. Right? It doesn't tell you anything about the ones that are above the isoquant that use too much input to get the same output. And we'll have a need for that in a while. But this is the standard notation. And that would shorten up an isoquant to this: the set of techniques that make output Q star is the Q star isoquant. Right? X such that f of x equals Q star. So if you're asked to write write down the definition of an isoquant, you could write it in words. You could write that, providing you set f is the production function. You have lots of choices. All are fine by me. I used to have a physical model. I lent it to somebody. Maybe I will find it again, but I don't think so. I think he's in France, and I don't know where the model is. But it's the same. Remember I showed you the picture of the corn production function, where I found the isoquants for corn last time? I had a physical model of that in cardboard. It was done in the 1950s. So now we get a formal item that we need to log. It's a cost function. It is the minimum amount of money, right, minimum amount of money necessary to buy the inputs that will produce output Q, is the cost of Q. That is worth memorizing. So if you want a definition for your pack of cards, which some of you have for other classes, I would put that one on it. It will save you a lot of work in what comes. Isocost lines we drew last time, right? The set of all input bundles that cost the same. X is an input bundle, and all of the x's for x1 and x2 cost I is another definition of isocost line. Just a straight line. It's the same thing as a budget constraint. But in this model, I don't know I. Remember, in the consumer model, I knew their income, so I could draw the line. There was only one. But there were many different curves, and I had to find the tangency. This model, there is one isoquant, one level of output. And I will draw many isocost lines and find the tangency. That's the way the two models relate. Otherwise, everything's the same. Once I get the tangency, it's all the same. So I tend to live in a world where there are two goods, because I like pollution. One good is other stuff. It's everything else in the world, and I make your life easy by deciding its price is one. That's just an assumption to make life easy. And the second is clean air services, the negative of pollution. Right? So I have two inputs, all the other stuff, and what I pay the garbage truck called the air to take away my waste products. Now here's the standard picture. I have drawn one isoquant, this guy, and this blue curved line is the set of input bundles that produces the same output. I haven't said what the output is, it doesn't matter. And then I've drawn three isocost lines. As usual, it's the three little bears. The one that costs too much, the one that costs too little, and the one that's just right. That's what all these models come down to. This one, everything on this line costs more than everything on this line, yeah? And if anyone wants to make me stop and go through it in more detail, you speak up. Otherwise, I assume you learned it last time we did this. Everything on this line more than everything on that line. So what are the possibilities here? Can you produce the output on the red line? No. So even though it costs less, there's no point on that line that produces the output. So if I'm looking for the minimum cost way to make the output, it is not down here. What about on this line? There's one point, the tangency. If you were redrawing this, you'd put a fat dot where you thought those two lines were tangent. And I can do that. Right, I can go get my pen. There's my pen. And I can mark the tangency. Right? So if you were going to do this on an exam and you were sloppy like me, and it wasn't obvious where the tangency was, put a big fat dot on it and say that's where it's tangent. That's good enough for our purposes. So that point is on the isoquant. It is on the isocost line. What about points up here? Well, a point like this does make the output, does it not? But everything on this line costs more than everything on this line. And so this costs more than this. And what will you do? You're looking for the least cost way. Bingo. You pick the tangency. Yep. Questions? So now we have a point on the cost curve. For one output, we're done. Here it suggests we can do a little exercise. We can go make a non-standard assumption, make the price of other stuff 2 instead of 1. And tell me the equations for the three lines and the cost of the chosen bundle. So, do you know how to do that? How many think they know how to do it? None? Nobody knows how to do this? How about an equation for a straight line? What's the equation for one of these lines in slope-intercept form? All right, so he's going for the right mx plus b. That's what he remembers. That's good. So how do I work it out here? Well, I find it's easier to start with I equals p stuff plus p air, right? Now I want to solve it for stuff, the thing on the vertical axis. Stuff equals I minus p a all over p stuff. So that must be m, yeah? And I over ps must be, from your formula, b, yeah? So you need the slope, right? You need I. First of all, you can find I pretty easily, can't you? If this is 60, what is I? The price of other stuff is 2. 60 divided by equals, so everything on this line costs 30. Everything on this line costs 40. Everything on that line costs 50, right? And if you want to complete this, then you need to count boxes. So take the blue line. We're 80 down and 40 over, otherwise known as minus 2. So minus PA over PS is minus 2. You already told PS is 2, and therefore PA is, if I got this right, 4, right? That's if I got it right. Nobody's screaming at me, so I'm going to assume my algebra is okay. So a standard exercise, in a course at this level, is for me to draw a straight line and tell you it's an isocost line, or it's a budget constraint, give you one fact, because you need one fact, then have you find out the other price and the income or the cost. Yeah? But for now, we know costs are 50, 40, 30 as drawn. And here I think we do exactly what I did, waving my hands in the air. So if you didn't follow me and you want to go look at a slide that has it on it, there it is. So wait, we did this backwards. You guys are not very. Is it that hot this afternoon? Wait a minute. So if there's 80 of these things and they cost 2 each, what's the answer? 160. Why do you trust me? Do you trust your professors? Are you crazy? This is the most crazy stuff. Okay, so we worked it out right, but the price is 4. That part at least I got right. And so we're at 120, 160, 200, right? Rather than the other way around. So let's look at this one. Everything on this line costs 160. I read out more carefully than you can the chosen bundle. Wait, 24 and 32. And hopefully, if you were to take the price of other stuff at 2 and the price of air at 4 and multiply these out and add them up, you would come back to 160. Is that going to happen? 4 times that is 96, right? And 2 times that is 64. When you add those two numbers together, you do indeed get 160. So this bundle really does cost 160 like it's supposed to. If you drew this freehand, would that happen? And you read the numbers off freehand? No, you'd mess it up, right? So it'd be off by a little bit. So if you do this, and you don't do it on graph paper, and you pick out a bundle and it doesn't come out exactly right, the reason is you haven't drawn it accurately enough. And for purposes of our exams, it's fine. Purposes of real life, not so good. So now we know the chosen bundle. I just read it off the graph. 24, this side's 32. I know the cost of the chosen bundle. I showed you the easy way to find that. It intersects here. Price up here is 2. 2 times 80 is 160. Right? So now we have the amount of other stuff and the amount of air that we would use to produce however much of this output there is, right, in the least cost fashion. And the cost of doing that is 160. So we have 1 point on a cost function. We have C of whatever this quantity is. Now I'm going to introduce 2 more quantities. I don't know what they are. I just know this quantity is lower and this quantity is higher, right? The green is higher than the blue. It's on a higher isoquant. More inputs make more output when we consider only efficient ways of making output. So now I have 3 tangencies on my diagram, and I can read off the costs in each case. The cost of making the lower amount, Q1, is 120. It's 2 times this. Cost of making this one, and you can see it's gotten sloppier, is 160. Cost of making this one is 200. So now I have 3 points on a cost curve. So if I had lots of isoquants, I could indeed produce lots of points on the cost curve. That's not the way we actually do business, but that's the way you could usefully think of it. Every time you have an isoquant, you can find the tangency, you can find an output. So the cost curve is just plotting Q1, Q2, Q3, I guess it's Q1, Q star, Q3, against 120, 160, 200. That's your cost curve. Now let's switch gears, and let's talk about a fundamental concept in pollution control. So now we're going to take this isoquant stuff we have, and we're going to use it on technology-based effluent standards, which are a mouthful. You start out with a technology. A technology is a way to make something. So a technology for an automobile would be all the other stuff you can think of. Instead of putting in a regular transmission, put in a 6-speed transmission. Right? That's literally a thing you could take your hands and stick in a car rather than the standard 5-speed transmission. So that is that's part of a technology. The whole technology would be a list of all the things you use to make the car. But I'm only thinking of changing one of them and keeping the others the same. So we have an idea what a technology is, a way to do something. So technology standard is, thou shalt make thy car having a 6-speed transmission. That would be a technology standard. You must do the thing that you are told to do. There are examples of technology standards, but it's not the one I gave. You think of something where you must do it the way they tell you. A technology standard. Yeah? Anything that you have to do their way, you're not free to do any way you please? Nothing? Yeah. They're not telling you the technology. You could do it with taking weight out of the car or putting in the 6-speed transmission, right? So it's not a technology standard. But it's a good question because it points out the difference, and that's where we're going. But we need a technology standard. That's a technology standard, yeah. So long as you say the car must have an airbag, it's a technology standard. If instead you said, in a head-on collision of such and such a force, not more than so many % of people can be broken in half, then it's not a technology standard. Then you can do it with an airbag or however you please. But the way you state it is technology standard on a car. So FDA approved what? How you do it, yeah. Right? It's not show us any way you please that your drug is safe. Right? They tell you how to do it, then it's a technology standard. If they told you any way you can demonstrate to us that the drug is safe is okay, then it's not a technology standard. So it's a technology standard, yeah. Well, you're thinking of labs. So there's some other technology standards for labs. May you wear a rayon sweater, a poly sweater into a lab? No. What happens to you if you do? Well, you can get burned to death, and that's actually what happened. And so it was a bad standard to violate. But you're supposed to wear a lab coat, right? And you're not supposed to wear flammable clothing. Those are technology standards. To go in a lab, there's tons of those that you have to obey. And they don't give you a choice. It's not, you can be fireproof any way you want. You can protect your eyes any way you want. You can't. If you are found without the protective equipment, you will be rapidly removed from the lab. Is that right? We have a consent decree, and I don't know what else will happen to you. But if I'm the principal investigator and I let you in the lab, I'm in a lot of trouble. And I have no defense. Okay, so yeah, for those of you who are lab types, that works. What else? Yeah, it's just banned. The technology you will use to heat your house is not this one. Fair enough. But now you're thinking about buildings. More technology standards in buildings? You build a building any way you like? No. What do you have to do? Give me an example of something you have to do in a building. Yeah. Yeah, so building codes in general are technology standards. And some of them will just say, if your building can withstand the following blah, 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 it's okay. Do it as you will. Other building codes are very precise. And they'll say, you must have windows that have the following technology in them. Then it's really a technology code. But be careful. If you say your window has to have an R rating of 23 or more or something, it's not a technology standard anymore. You say you must use double pane windows, it is. So a lot of things you think of are technology standards are probably not. But things like your electric outlets will be grounded. Do you have a choice? No. That's technology standard. So now we have technology standards. You got to do it a particular way. Here's an example. There's the other example, and you came up with the rest. So one way to reduce emissions is a technology standard. You're going to build a new building. It has to have the following things in it that make it energy efficient. That's a technology standard. That reduces the use of energy. Cars, catalytic converters. If you said your car must have a catalytic converter, it's a technology standard. But that's actually not what it says. What it says is your car may not emit more than and give some amount of grams of NOx per some number of miles. Right? And so it's actually not a technology standard. You're free to do it however you please. Next object is an effluent standard. So you're actually limited in how much you can emit to the environment. Like my previous example, so many grams of NOx per 100 kilometers driven. If you actually look up these standards, they're really horrible. They tend to be in grams per 100 miles, showing a real understanding of keeping your units consistent. But still, that's an emission standard. In that case, it's emissions per unit output. Number of tons of NOx you may emit in a power plant per megawatt hour produced. Emission standard per unit output. Number of tons of NOx per year. That's an absolute emission standard. Nothing you do makes it go up or down. And you're going to see very common these and those. Those are the two most common types of emission standards. Either, as in Southern California, your plant can emit no more than so many tons of NOx regardless of what you do. Straight out emission standard. Or, as in the Clean Water Act, they tended to be given effluent standards based upon how much would be produced if the plant ran full time. That'd be per unit output. Oh, and there's another example. How much comes out per ton of coal burned per unit of emissions? That's inputs. That's possible too. It has been done. But the real common ones are absolute or per unit output. Okay? And obviously you can get some different results depending on what you choose. If you choose an absolute number, then assuming you can enforce it, you're guaranteed to have that number. If you choose per unit output, then you're always in danger that output and emissions will both go up. If you're in a place where you can't stand the additional emissions, like Los Angeles, or Beijing, right? Then you don't want to risk that. You want to have an absolute number. And these things get written down. This is one of our light-duty vehicles emission standard, and you notice it's in grams per mile. That just blows me away. What were they thinking? And you get all the different types of cars, and you get carbon monoxide, NOx, PM. I don't know what this guy is. Non-methane organic gases, and we're different from other places in the way we classify. PM, what's HCO? Formaldehyde, and then per 100,000 miles and for 10 years. Right? And so those are our standards for cars. If you meet the standards, you meet the standards. You met the standard with a catalytic converter? Wonderful. You met the standard by burning things more efficiently? Wonderful. We don't care how you meet the standards. It's up to you. They are emission standards. They are not technology standards. So California has effluent standards. You can do it however you want. Is that a good thing or a bad thing? Why? Well, wait a minute. There's two ways. I'm just going to hold you to this one. So there's two ways, right? I mean, the standard is clear. For 50,000 miles, it's so many grams of NOx. So if you use a catalytic converter, you'll be at that or under, and if you do something else, you'll be at that or under. So why does the environment care? Well, I like the fact that you're willing to engage rather than go to sleep, so thank you. But why does the environment care? Or you're seeing it my way now? Okay, that's fair, and thank you for chiming in. But look, no, this is it. It's set so you can breathe in LA. Well, they're going to breathe too much. Right. Well, if you're going to let them just breathe in LA and not be unhealthy, and you go to a place that has less cars, you're going to be too healthy, right? You should have let them emit more, but that's not really the discussion here. The discussion just is, how do I meet this? Why is it good that I can meet it any way I want? Right? So the breathing's going to be the same. However you meet this, the guys in LA are still going to go, it's going to be okay. Why do you want to do it anyway?